Hello everyone! Today I'm excited to share findings that were recently accepted for publication in the Journal of Chemical Education. Matthew Doris, a PhD student in food science who has also worked as a chemistry educator, worked with me on this project. The study involved 121 undergraduate students who had never taken a college-level chemistry course before. We gave them introductory level instruction about topics related to atomic structure. So what are atoms, what subatomic particles within atoms exist, like electrons, and so forth. The materials included energy diagrams like this one. This type of energy diagram uses small arrows to show electrons within atoms and which regions within the atom they occupy. Chemistry instruction broadly uses a large variety of energy diagrams for a variety of topics related to atoms, molecules, and energy. Then we conducted interviews with the students and we asked them questions about how energy diagrams depict electrons, which are an important subatomic particle that explains many characteristics of atoms and matter. We found that students had many misconceptions about atoms, some of which seemed to result from the design of the diagrams. For example, students wrongly thought that the small arrows mean that electrons move towards the nucleus of an atom or away from it. Quick side note, this is wrong. Instead, the direction of the small arrows describes the direction of a magnetic field that results from the intrinsic angular moment of the electron. Another example from this data was the use of chemistry language. The instruction we provided students with made disclaimers, such as that what students were learning applied to atoms in their ground state. The ground state means that an atom is in its lowest possible energy state. In contrast, if an atom is excited, for example because it absorbs light, it is no longer in its ground state. However, students in our study thought ground state means an atom does not have a magnetic field attached to it, or that it is not in an ionic state after having lost or gained an electron. This finding was surprising to us because the term ground state is often used without explanation in chemistry textbooks. Altogether, what was eye-opening to both of us was how difficult it is for students to interpret arrows in chemistry diagrams. So let's take a look again at all the varieties of energy diagrams chemistry students encounter in their learning and how many arrows there are. The different arrows have different meanings, and this meaning is not explained. Textbooks don't explain their meaning in a caption of the figure, and most instructors do not explain them either. And confusions about the meaning of arrows can cause misconceptions about, for example, how electrons behave. And that can be detrimental to future learning about chemical concepts, especially if this goes unnoticed by instructors. So it is important to understand how students interpret these diagrams because this will enable us to address misconceptions before they solidify and cause issues when students learn more advanced chemistry concepts. So, thank you for listening today.